God, it's day 3. Day 3 notes, kids. I have to tell you, I'm going to need some coffee soon because I'm dying. I don't know why. I don't know if I can get soup. This is day 3 notes. All right, I'm going to do this one, and I'm going to take off for a little while and go get some work done today. So here we go, day 3 notes. Let's see what we got. I think what we're going to have is a radical party. I'm not even sure, but I'm pretty sure. Oh, it's radical party time. Oh, my God, I'm so excited. Yeah. Let's make a list of all of our perfect squares. If you had good teachers from previous, and I know you did, you should know all your perfect squares up through 10,000. Well, not quite. So let's go. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Everybody knows those. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196, and 15 squared is 225. I'll expect that you know all of those. You should just have those right there in the old memory bank. And then the other ones that are kind of cool, if you do 20 squared, well, 2 squared is 4, 20 squared is 400. 30 squared, 3 squared is 9, 30 squared is 900. 40 squared, 4 squared is 16, so that's 1600. 50 squared is 2,500, 60 squared is 3,600, and then 4,900 is 70 squared, and then 6,400 is 80 squared, 8,100 is 90 squared, and 10 squared is 100, 100s, or 10,000. So those are all radicals that you should say, you should know how to do. So what we're going to do is we are going to learn to simplify radicals again. I know you did this in 9th grade, but then we're going to take it to an Algebra 2 level. I hope you enjoy this. That's a little foreshadowing to come. Don't just fall into the perfect square trap, like the one you know, right? So what I like to do is, this is the way I like to do it. I like to divide the number in half, just to get a place to start looking on this list. Then I'm going to write it as a perfect square equal to or less than that number. And you'll see, we'll rewrite it and we'll do it. So we're going to go through these steps. I'll show you how we do these steps. I'm going to put it right here. These are my Krauss's rules to rationalizing or to simplifying radicals. So if I take 48 and I cut it in half, it's 24. 24 is not a perfect square, but it gives me the place to start looking on my list. So 24 is right here. So I only need to worry about these numbers, and you never need to worry about 1 when we're simplifying radicals because 1 is boring. So it's either 9 or 4, 9, or 16, and we're going to try the largest number. If that doesn't work, we'll try 9. If that doesn't work, we'll try 4. Now I know 4 goes into it because I know 4 goes into it. I'm not sure about 9 or 16, so I could come over to the dumb machine, or I could just use my brain. And I know that this is really equal to the square root of 16 times 3, because 16 times 3 is 48. Now, so I find the largest perfect square, it's 16. I'm going to rewrite it as the product of the perfect square and the other number. In this case, the other number is 3. And then I'm going to take the square root of the one that I can. This is 4, so I end up with 4. It's a 3. We'll keep practicing. Square root of 60. Cut 60 in half, I get 30. So if I start looking under 30, that's 25, 16, 9, and 4. Well, there's only one of these that goes into 60, and that just happens to be 4 this time. So we're going to do the square root of 4 times 15. What's the square root of 4? It's 2. Square roots of 15. Let's do 125. If I cut 125 in half, it's actually 64.5. Around 64. So 64, 49, 36, 25, 16, 9, 4, and 1. So I know 64 doesn't go into it. 49 doesn't go into it. It's odd. 36 is going to go into it. It's clearly 25. So I'm going to rewrite it as 25 times 5, right? Isn't 5 quarters $1.25? Square root of 25 is 5, so this becomes 5 square roots of 5. 300. Now, listen, kids. If it's got 100 in it, it's 100. So this is just 100 times 3. Don't overthink that one. That one's crazy. When it's 100's in it, when it's got double zeros at the end, your perfect square is 100. Square root of 100 is 10, so this becomes 10 square roots of 3. Now here's the one we math teachers love to ask, because every fool that doesn't listen to me writes 9 times 8 and says, okay, this is 3 square roots of 8. Excuse me. 3 square roots of 8. Which is completely the wrong answer. I mean, it's their equivalent, but it's not simplified. So what we want to do is simplify this. So if I say cut this in half, if I cut 72 in half, I get 36. Oh, wait a second. 36 is a perfect square. That's the largest perfect square that goes in, 36 times 2. And the square root of 36 is 6. So we end up with 6 times 2. So that's that. Oh, wait. Now what do we do when we have a number out front? No problem. We're going to do the same thing. So it's 3 times. I'll cut 24 in half. I get 12. So let's see. It's either got to be a 9 or a 4. 9 doesn't go into 24. So this has to be 4 times 6. What's the square root of 4? It's 2. So what we end up with is 3 times 2 times the square root of 6. Now the one you cross off, which is always going to be the perfect square, comes out front, and then the thing that's left over stays underneath. Well, this is 6 square roots of 6. Let's do another one. So this is going to be 9 times the square root of something. So if I cut 80 in half, I get 40. All right, so the first perfect square under 40 is 36. That doesn't go into 80. 25, that doesn't go into 80. 16, maybe. Come over to the dumb machine. Say 80 divided by 16. And you'll see that's 5. So we're like, oh, okay, 16 times 5. Now, if you did not do that, you might just rely on 4, because I know 4 goes into it, but that's not the biggest. Square root of 16 is 4, so this becomes 9 times 4 square roots of 5. So that's 36 square roots of 5. Oh, fractions. Fractions are awful. So half of 108 is 54. So we'll start looking at our list. The first perfect square under 54 is 49, then 36, then 25. I know 25 doesn't go into it. 16, 9, and 4. So 9 does go into this. 1 plus 8 is 9. So 9 would be a good choice. But is it the biggest? We don't start there. 4 also goes into it. But I know 4 is not the biggest because at least 9 goes into it. So I either got to try 16 or 36 or 49. So I could try all of those. I know 49 doesn't, but just for fun, just divide by 49. And if it ends up with a fraction like that, you know it didn't. Then I'll do 108 divided by 36. And oh my goodness, it goes in there 3 times. And you may not have known that, but that's okay. That's what the calculator is for. 36 times 3. The square root of 36 is 6. So we're going to do 1/2 times 6 square roots of 3. Notice the square root of 3 stays under. Half of 6 is 3. So this is really just 3 square roots of 3. What about a variable underneath it? Well, let's just take a look at this. What if I didn't have this? What if I had this? The square root of 3 squared. Well, what is 3 squared? Isn't 3 squared really 9? So wouldn't this just be equal to 3? So here's what I want you to think about. What you have here is a square root. And what you have here is a square. A square and a square root, they kind of cancel each other out. Now, when we get into some rational exponents, you're going to see why. But a square and a square root, in effect, just cancel each other out. So the square root of x squared is just x. Now, this one's a little different. I'm going to rewrite this a little bit different way. I'm going to rewrite it like this, and then we're going to see if we can come up with a generalization. So what if I wrote this as y4 as y squared times y squared? Well, what is the square root of y squared? That's just y. What is the square root of y squared? Oh, that's just y. Y times y is y squared. What you're going to find out is this square root cancels out 2 of the exponents, right? So if we have 4, so that means we have 4 of them, we're going to divide it by 2. So for every group of 2, they kind of cancel each other out. So this ends up just being y squared. So you're going to take this 4 and you're going to divide it by 2 to get this. Now, I'll do it one more time. This is equal to z squared times z squared times z squared. In other words, how many groups of 2 do you have? We have 3 groups of 2 because a square root and a square cancel each other out. So this just becomes z, this just becomes z, and this just becomes z, which is z cubed. In other words, for every 2, so we're going to divide by 2, and we get 3, so this becomes z cubed. Now, I don't want to write this out 16 times. That's crazy. So I know 16. How many groups of 2 is that? Oh, that's 8. So this is really x to the 8th. If I had the square root of p to the 24th, well, how many groups of 2 are there in 24? There are 12, so this would be p to the 12th. All right, now, odd exponents are a wee bit trickier, just a wee bit. So what we're going to do is we're going to do the same thing we did with these up here. We're going to write it as a perfect square and then not a perfect square. So let's take a look. We want to write this, whatever this number is, we want to write it as the highest even number we can write. So what we're going to rewrite it as is n squared times n. Would you agree that's n cubed? I hope so. I hope so. And then again, for every 2, we can take out 1. So this is n square roots of n. You'll see in a second. Watch what we got. All right, we're going to do this one is m to the 4th times m, because that makes m to the 5th. Now, again, for every 2 of these, we can take out 1. In other words, we take the 4 and divide by 2. We end up with m squared, square roots of m. What's the highest even number next to 7? That would be 6. So this is x to the 6 times x. We'll take the 6, we'll divide it by 2, and we get x cubed, square roots of x. And 11, the highest even number next to 11 is 10. So we're going to write this as the square root of y to the 10th times y, because that makes up 11 y's, this makes up 7 y's, this makes up 4 m's, this makes up 3 n's, and I should have said 7 x's. So how many groups of 2 are there here? 5. So this is y to the 5th times y. You will get better at this. If you practice it, you'll get better at it. All right. So let's just go hog wild now. Let me pause for a second. All right, kiddies, let's go a little crazy. So we're gonna put it all together now. Okay, we're gonna put it all together. So we're gonna start with 2 times. Let's deal with the number. If I take 32 and it's not a perfect square, but if I divide it by 2, I get 16. And 16 is a perfect square. So we're going to rewrite this as 16 times 2. So our whole goal is to write it as a perfect square and some other leftover number. And we're going to do that over and over again. We're going to do it with variables and we're going to do it with numbers. So x to the 4th. As long as it's even, we're going to leave it. It's x to the 4th. But as soon as it's an odd number, we're going to write it as an even multiple of 2 and an odd. It's always going to be a leftover one for these. So it's going to be y squared times y. Now, I haven't changed anything. This is still 32. This is still x to the 4th. And this is still y cubed. I've just rewritten it as a perfect square and not a perfect square. So we're going to do this a little bit quicker. This is 4, right? So 4 times 2 is 8. The square root of x to the fourth is x squared. Remember, we'll take the 4 and divide by 2. The square root of y squared, 2 divided by 2 is 1, so that's just y. Now, everything you didn't take the square root of, the 2 and the y stay under the radical. All right, we're going to do another one. Rewind it and take a look at it if you missed something. All right, we're going to leave the negative 6 and the m out front. Now, we're going to take 24 and we're going to divide by 2. That's 12. Well, 12 is not a perfect square, so that's not going to work for me. 9 doesn't go into 24. 4 does. So we're going to do 4. So we're going to do 4 times 6. Now, with the variables, we're going to write it as an even and not an even. So this becomes m to the fourth. I hate m's. M, that's m5. N to the fourth. N, that's n5. And p is already to the fourth, so we'll just leave that as 4. Okay. I'm going to do this one a little bit slower. Negative 6m times, this is 2, times, this is m squared, times, this is n squared, times, this is p squared. And then square roots of, I didn't cross off this, I didn't cross off this, and I didn't cross off this, 6 mn. Well, that's not the final answer, because I can put the negative 6 and the 2 together. That's negative 12. This m and this m can go together. That's m cubed. N squared, p squared, square roots of 6m. All right, now we're just going to get cray-cray. Got fractions. 1/2 h times j times k squared, square roots of. Now 20 divided by 2 is 10. The only perfect squares that are less than 10 are 9 and 4. Clearly it's 4 times 5. And then h to the 7th, I'm going to write as h to the 6th times h. That's 7 h's. There's 7 h's. This is 20. J squared, well, that's already even, so I'm going to leave that as j squared. And then k cubed, I'm going to write k squared times k. All right. So negative 1/2 h times j times k squared, square roots of, oops, excuse me. So now we're going to take the square root of 4. That's 2. We can't take the square root of 5. I don't know the square root of 5. Square root of h to the 6th is h cubed. Can't take the square root of h. The square root of j squared is j. And the square root of k squared is k. And then what do we have left over that we didn't take out? Let me move that up. Is 5h and a k, I think, right? 5 and h and a k. All right, let's put all this crap together. 1/2 and 2 go together. It's actually negative 1/2 times positive 2 is negative 1. Don't have to put a 1 there if you don't want. H and h cubed is h to the 4th. And then j and j make j squared. And then k squared and k make k cubed. Square roots of 5hk. Holy crapola. All right, so that's that. All right, let's talk about another rule of these things. Another rule says if you have one radical or a fraction under the radical, you can break it up. So, for example, if I had the square root of, 49 over 64, well, that fraction doesn't reduce, but I can rewrite it as the square root of 49 over the square root of 64. And then I say, oh, okay, the square root of 49 is 7. Square root of 64 is 8. And I can just rewrite it like that. And so that's what we're going to be doing now. I'm going to play around with some more of these fractions. So, let's do this. we're going to rewrite. Now, this can't be simplified. There's no number that goes into 30. Oh, there is a number that goes into 30s, but I'm not going to rewrite it. I'm just going to do this. I'm going to rewrite it as square root of 45 over the square root of 36. Now, luckily for me, the square root of 36 is just 6. That's easy. The square root of 45, though, is, we're going to write this as 9 times 5, right? You all know that 9 times 5 is 45. All right, the square root of 9 is 3, so this becomes 3 square roots of 5 over 6. Now, can't that 3 over 6 reduce to 1/2? 3 goes into 6 twice. So we end up with the square root of 5 over 2. Odd. All right, let's take a look at this one. We're going to rewrite this one as, well, this one's a little bit different. This one I can actually do some division with. So 16 actually goes into 48 3 times. So that leaves me a square root of 3 on top. Well, let's do that. Leaves me a 3. And then I've got 7 x's on top and 2 x's on the bottom. So those cancel with 2 of these. That leaves me 5. So this is really the square root of 3x to the 5th. Now, that can be simplified. You can't do anything with the 3, but the x to the 5th can be written as x to the 4th times x. And what is the square root of x to the 4th? It's x squared, square roots of 3x. All right, this one gets a little weird. Let's see. Nothing goes into 25 that goes into 28. I can get rid of one of these with one of these. That leaves me 2. I can get rid of 6 of these with 6 of these. That leaves me 4. So what I end up with is negative 3 times 28 y squared over 25 z to the 4th. Now, well, let's just rewrite it, negative 3. The numerator I'm going to rewrite as 4 times 7, that's 28. Y squared is already even, so I'll leave that as y squared. And the bottom, the square root of 25 is just 5. The square root of z to the 4th is just z squared, so I'll just leave that. So the only thing I got left to clean up is this square root of 4 here, and that would be 2. So what do I end up with? Remember, because this is really negative 3 over 1, I end up with negative 6 square roots of 7y squared over 5z squared. All right, we're going to practice a few more. All right, the other thing you could do, if you'd like to, is if they are split up like these are, you could write them underneath each other. You could just redo this. You could rewrite it like this, 80. You can say, okay, I don't like this. I'm going to go back because I know I can do some simplifying all over 5x. And I could say, okay, I could rewrite it. I could take it from 2 and make it from 1. So you can go in either direction. If it's 1, you can make it into split it up. Or if it's split up, you can combine them underneath 1. Well, why would I want to do that? Well, look at this. 5 goes into there 16 times. This 1x cancels with one of these and leaves me 2. So what I end up with is nothing in the denominator, so yay, no more fractions. But what I end up with is 16x squared. Now this is y to the 5th. Can I write that as y to the 4th times y? I just wanted to kind of speed things up a little bit because I already know 16 is a perfect square. So if I take the square root of 16, I get 4. The square root of x squared is x. The square root of y to the 4th is y squared. So the only thing left under the radical is the square root of y. It's hard to believe, I know, that that weird, complicated thing became that. But that's true. Almost done, children. I think. I don't even know. Is there another page? So we're going to do negative 2 over 5. I'm not going to split this up just yet. because I think I can simplify it. Doesn't 5 go in here 9 times? And 5 goes in here 25 times? I should be using a different pen. And I can get rid of 5 of these with 5 of these, right? So what I end up with is, I'm going to split it up now. 25k to the 5th over the square root of 9. So this becomes negative 2/5 times the square root of 25. This is k4k over, well, what's the square root of 9? That's just 3. So let's figure this stuff out. This is just 5. Well, that 5 and that 5 cancel. K to the 4th is k squared. So what do I end up with on top? Negative 2 k squared times the square root of, this is still under the radical, k over 3. Ooh, that's a tough one. So what do we got here? Negative 3 over 2 square roots of, ooh, what am I doing? Let's see if we can simplify this. I can't do anything 25 and 28, but this one of these goes with one of these. That leaves me 2. 6 of these go with 6 of those. That leaves me 4. So I end up with, all right, let's try to write this out. These are gone. So in the numerator, we're going to do 4 times 7, and then y squared. And the denominator, we're going to do the square root of 25z to the 4th. All right. This is negative 3 over 2 times 2y square roots of 7 over 5 z squared. All right, does anything cancel here? I think we got a little bit that cancels. These go. So I end up with negative 3y square roots of 7 over 5z squared. Woo! Crazy. And now we have a third rule. And our third rule is a little weird. I hope you enjoy it. And here's the problem. What are we going to do when we end up with a negative under the radical? In other words, what is the square root of negative 25? Up until now, you would have probably told me that I must be on something. But when I come back, which is going to be like 2 seconds, we're going to talk about that. So, if mathematics wasn't hard enough, we are now going to introduce you to an imaginary number called I. Yes, I. When you write I for me, I want you to write it like this. Little bubble, little I. Make sure you understand it's I, the imaginary number I. So I is defined in mathematics as the square root of negative 1. So this is the definition of I. I is equal to the square root of negative 1. Now, one of the biggest things you're going to have to remember is when dealing with I is that I squared is equal to negative 1. Well, let's think about that. If I had the square root of negative 1 and I squared it, doesn't this square and this square root cancel each other out? Sure. So what would I get? I would get negative 1. But if I wrote this as not the square root of negative 1, I wrote this as I squared. I squared is equal to negative 1 for that very reason. And this is going to become huge in the I world. So I hope you understand it. So let's check this out. What's the square root of negative 25? Well, the square root of 25 is 5. And the square root, anytime you have the negative underneath a square root and only a square root, you will have I out as an answer. So what would be the square root of negative 25x squared? Well, the square root of negative is I. The square root of 25 is 5, and the square root of x squared is just simply x. Let's play with I for a little bit. We said that I is equal to the square root of negative 1. We also then said, what do we do with I squared? I squared is simply equal to negative 1. Now we get a little weird. What is I cubed? Can I rewrite I cubed as I squared times I? I would hope so. Get that joke? It's pretty funny. Well, what is I squared? Isn't this just negative 1? Sure. So this becomes negative I. Okay. I'm going to rewrite this one as I squared times I squared. Well, I squared is negative 1 times negative 1. So this just turns out to be 1. So I is, by definition, the square root of negative 1. I squared is negative 1. I cubed is negative I. And I to the 4th is 1. Now we're going to see if we can come up with some generalizations. I to the 5th. I'm going to rewrite I to the 5th as I to the 4th times I. Well, what is I to the 4th? It's just 1. Oh, so that just kind of goes away. It's just 1. 1 times I is I. I to the 6th is I to the 4th times I squared. Well, I to the 4th is just 1. I squared is negative 1. So this is 1 times negative 1, which is negative 1. I to the 7th is I to the 4th times I cubed. Well, I to the 4th is 1 times I cubed, which is negative I. Right? I cubed is negative 1. And then I to the 8th, isn't that just I to the 4th times I to the 4th? Which is 1 times 1, or 1. So you're going to see that every multiple of 4 is just 1. Every multiple of 4. So if I wrote this I to the 9th, I could write this as I to the 8th times I, which is just I. I can rewrite this as I to the 8th times I squared. I to the 8th is just 1, so we don't need that. I squared is negative 1. I to the 11th is I to the 8th times I cubed. Well, we know I cubed is negative I, so this is just 1 times negative I, which is negative I. And then this one right here is I to the 13th, so this is I to the 12th times I. I to the 12th is a multiple of 4, so this is 1, so this is just I. I think you get that this is going to be negative 1, negative I, and 1. Now, the cool thing is, kids, calculator does it for you. But we're going to get that in a second. Man. Well, let me just go through that real quick. The calculator is going to do this for us. I'm going to do this at the end. So those of you like stressed out about the I stuff, I hope you don't freak out because I want you to be successful in math. The calculator will do this for us. If I come over here and hit the pi button, you'll see that the imaginary number I is right there. So if I want I raised to the 8th, and I don't know what that is, oh, it's 1. I raised to the 14th, oh, that's negative 1. I raised to the, I don't know, 34th. Oh, that's negative 1. I raised to the, I don't know, 33rd. Oh, that's I. I raised to the 35th. Oh, that's negative I. It'll do it for us. We're good. The only thing I want you to remember from this whole thing, and I'm not going to stress this out. Trust me, I'm not going to stress this out because I know you can do this on your calculator. I don't really care about that. What I do care about is that when you get something like this, that you can quickly simplify it. The only thing I really want you to remember is when we're dealing with square roots and only square roots, that when you have a negative, you know I is going to be in your answer. Anytime you take the square root of a negative, I is going to be in your answer. So here's how we're going to rewrite these from now on. Negative 20. Cut it in half. You get 10. Well, the only perfect square under 10 that goes into 20 is 4. So I'm going to rewrite this as 4 times 5. And then x squared is already even, so I'm going to leave it. So what is the square root of 4? 2. What is the square root of negative? I. So this is 2i. That's x, square roots of 5. The only difference is we're now going to have an I in our answer. So, 10. If I cut 98 in half, I get 49. Oh, that's a perfect square. So I'm going to rewrite this as negative 49 times 2. Now I got to write these as evens and leftover evens. So a squared, a, that's a cubed, times b to the 8th. 8's already even, so we're good with that. So let's see. The square root of 49 is 7, so the square root of negative 49 is 7i. So this is 10 times 7i times a times b to the 4th. And what do we have left over? 2a. So we're almost done. This is 70i, a, b to the 4th, square roots of 2a. And let's just split this sucker up. Square root of negative 9y to the 4th over square root of 64. The square root of 9 is 3i. The square root of negative 9 is 3i. The square root of y to the 4th is y squared over square root of 64, which is just 8. All right, got a bunch of practice problems. Let's get through these. So I think we've already done 72 already. We know that's going to be negative 36 times 2. Always put the negative first because it's going to remind you to put that I in your answer. And then everything else is just evens or not evens. K squared, K, M6, M, N6. And then everything that's not a perfect square goes. So the square root of negative 36 is 6i, K, M cubed, N cubed, square roots of 2k m. Be neat, kids. Be neat. Be neat. All right. Square root of negative 49. Now, I'm not going to change negative 49 because it's already a perfect square. I'm just going to leave it. X, y squared y. And the denominator is the square root of 100. So, what's the square root of negative 49? It is 7i. The square root of y squared is y. And what do we have left over? Square roots of x, y over square root of 100 is just 10. All right, last one. 7. Oh, what do we got here? 7. That's a perfect square. That's a perfect square. That's a perfect square. And that's a perfect square. We're in good shape. 7 times square root of 400 is 20. So this is 20i. X, y squared, z to the 4th, right? X, y squared, z to the 4th. So what do we have here? 140i, x, y squared, z to the 4th. The big thing you got to remember about a negative under a square root is it has nothing to do with being negative. It is simply the imaginary number I, or the imaginary symbol I. All right, here we go. This becomes I to the 7th. So I'm just going to rewrite that. Literally, if you just write it as single i's, squareds, or fourths, you're in great shape. So I'm going to rewrite this as I to the 4th times I squared times I. Well, I to the 4th is 1, so this is 1. I squared is negative 1. That's important. That's the key to being able to get done i's. And then this is just I. So this whole thing just becomes negative I. This becomes I to the 5th. right? You just add the exponents. So I'm going to rewrite this as I to the fourth times I. I to the fourth times I. Well, I to the fourth is just 1, so this whole thing is just 1 times I, which is just I. And again, your calculator will do this for you. I'm going to show you one more example of this. This is I to the 15th. So I'm going to rewrite this as I to the 12th, because that's a multiple of 4. What does that leave me? 3. So that means I squared, because I know something about I squared, and then I. So this is 1. I don't even care about it. This is negative 1. Right? This is negative 1 times I, so this becomes negative I. 3 more. Now, exponents raised to exponents, you just multiply them. So this becomes I to the 8th. Well, isn't that a multiple of 4? Sure. So this is just 1. Because I to the 4th is 1. So that's easy. This is I to the 21st. So I'm going to rewrite that as a multiple of 4, which is 20, times whatever is left over, which is I. This is just 1. So this just becomes I. And this is just I to the 4th, which is just 1. And again, I'll do one that's complicated. Let me do this one over here. This one that turned out to be negative I. So I to the 10th times I to the 5th. Our calculator will do this for us. So parenthesis, I raised to the 10th. Parenthesis. You can't click on the I letter down here. You have to go in there and click on that I there, because that's the imaginary number I. And you get negative I. That's all it is. There she goes. That's day 3, which may end up being 2 days this year. We'll see. I don't know. That's a lot of information covered. We got a lot of work to do and a lot of practice to do. So we're going to have to play around with that one. All right, kids. Catch y'all on the flip side.